In the first video, perspective taught us that all parallel lines and planes angle to our eye position. But will those parallel lines and planes angle up to our eye level if we go high up like atop a tall building or from an airplane or from over 100,000 feet in a weather balloon? Will the horizon still be eye level? That's what we'll be looking at in this video, but let's review. All of the lines converge at a center point on the horizon called the vanishing point. Parallel lines above it angle down, the lines below angle up, the sides angle in. The vanishing point is the intersection of the horizontal and vertical axis of our eye position. It's parallel all the way out, parallel with the ground. That's why I say you can't look down at the horizon, because the horizon angles up to your eye level. The two, your eye level and the ground plane, are parallel all the way to the horizon, but it's the bottom ground plane that angles up to your eye level. Also, the vanishing lines tell us where the camera was when the photo was taken. You can't look down at the horizon because the horizon is at the height of our eye plane. It's not where your eyes are looking that determines the horizon, but where your eyes are located. It's the height of your eyes relative to the ground. Our eyes work like this. Our eyes shape what we see into a cone. All parallel lines and planes angle to the plane of our eye level. Here you can see parallel lines made up of bricks on the walls. The wall on the left, though, is headed out towards the horizon, and all the lines angle toward the eye level of the observer. The bottom ones angle up and the top ones angle down. The horizon would not be eye level, but visually ground level if the bricks angled down to the floor like this. That the parallel lines do not angle or converge towards the ground, nor do they angle towards the ceiling, nor to the left or right. They angle to the eye level of the observer. This image is a product of our eyes. These are horizontal parallel lines, yet we see them not as parallel, but on an angle towards a point in the distance. Now, of course, we know that they are parallel, but they visually are not. These lines are visually parallel. Our eyes visually intersect the parallel lines at the horizon. And the horizon is always a straight line because it's always eye level. And we know it's always eye level because it's always a straight line. Straight line, straight horizon. Sitting in a boat in the middle of the ocean, you will be encompassed by a 360-degree horizon that's a straight line and it's eye level. Here's an illustration. Try this out for yourself. You'll need a flat circle like a hula hoop. The only way to make that 360-degree circle appear as a straight line is to position it so that it is perfectly on plane and level with your eyes. Go ahead and give it a try. Perspective demands straight level parallel lines and planes. A progressively downward sloping Earth is not a straight parallel line, so I don't know that it would make it to the eye level horizon, and as we know, all horizons are eye level because they're all straight lines. So I really have my doubts as to whether or not the Earth is a globe. Globe or a ball, at some point it would be below eye level because the ground is sloping away. It's sloping away right from the observer. Wherever you are, you're on top of the world. You are the high point on a ball. So the ground slopes down away from you. But there is the law of perspective. But again, like I said in the last slide, perspective works with straight, level, parallel lines. And a downward sloping Earth is not a parallel or a straight line. So, some would say, well, but it's such a gradual slope. I've seen videos all over YouTube where they're looking out at a water horizon that doesn't look very far, a few miles out, and they're saying it's obscuring a building behind it. Well, that's quite a bit of curvature, wouldn't you say? It could obscure a 10-foot, 12-foot building behind a wall of water. So I would think at some point you would see you would have to look down at the horizon and it would look like a curve. The horizon line would be curved, but we haven't witnessed that. We don't see that. I go in this video, I'll go all the way up to over 100,000 feet and it's a straight line. So here I've overlaid a hallway over the water so that you could see perspective at work. It works in the hallway the same as it works on the water. It's just that over the water there is no walls and there's no ceiling, but the principle's the same. And then I take this hallway, I fill it with water and spread it out so that it equals the horizon up to the horizon line, and then remove the top half and you have the same lower plane horizon, as I call it. Next, I'll demonstrate perspective with a couple of pictures inside long corridors. If you're thinking the horizon is produced by the curvature of the Earth, you'll see that the horizon and vanishing point is formed in a relatively short distance. You cannot attribute the horizon and vanishing point that is formed in these pictures to any kind of curvature. Okay, and here's what we could expect to see if the Earth were concave. The horizon would be above eye level and it would be curving upward. We do not observe a concave or convex horizon. The horizon we observe is always a straight line, and as we've learned in this presentation, a straight horizon line means the horizon is eye level. This one we observe, the others we do not. Let's go up higher and see if perspective still holds true. A camera height of 1,368 feet, the horizon line eye level, and it's dead straight. This is atop the old World Trade Center. How do we know the horizon is eye level? In order for our 360-degree circular horizon to appear as a level straight line, it must be eye level. Try holding a hula hoop up around eye level and position it until it becomes a straight line. Here we have all parallel lines and planes, yet they look as though they converge, and they converge at a point on the horizon called the vanishing point. Everybody sees their own horizon depending on where they are and how high up they are, because the horizon is a product of our eyes. Again, it's our eye height that dictates the height of the horizon. Let's add some brick walls to the sides of the World Trade Center so we can see those parallel lines. Laws of perspective have not changed just because we're higher up off the ground. You now know that the horizon is eye level and that it's a product of your eyes. The converging horizontal parallel lines to your eye level proves it. If you had a big window at the end of this hall, the horizon would be at your eye level, and the lines on the walls would verify that. Well, that completes our review of perspective. Let's go higher up and see if the horizon still remains a straight line and still eye level. Straight line, eye level. How about atop Mount Everest? Again, that's a straight line. Remember our hula hoop, it's got to be eye level. Again, Mount Everest, straight line, eye level. And one more time, straight line, eye level. How about from an airplane window 30 or so thousand feet up? Straight line, eye level. Straight line, eye level. Never changes. Just wanted to throw a little more in here about the about perspective. In this, with this photograph, you can see I have the XY axis, that's the horizontal and the vertical axis, and then you have the Z axis, which is the longitudinal axis. That's from your eyes to the vanishing point. Now, I pointed out, and I marked it with a green line, that airplane streaking across the sky. So that's probably, let's say that's 38,000 feet, and the airplane here that you can see the wing of is 30,000 feet. So I'm going to assume that airplane streaking across the sky is at its cruising altitude and it's parallel to the ground. Well, one thing you'll notice that, and this is what perspective demands that straight, level, parallel, that's the key, parallel lines and planes will angle to the horizon and the vanishing point. Okay, that's all the red lines. Those are all going to the vanishing point on the horizon. That's if they're level, if they're parallel, straight lines and planes. Okay, now that green line represents the flight of that plane. Now you can see that it's probably parallel to the ground. It's parallel to the x-axis, therefore it'll bring it down to the horizon, and that's where it'll disappear. Now why isn't it headed for the vanishing point? Well, the reason is because it's not parallel to the z-axis or the longitudinal axis. If it were parallel with that, it would follow one of the red lines that take you right to the vanishing point. The exponentially downward curving Earth could not make it to the eye level horizon. And again, how do we know that it's eye level? A lot of people get irritated with that. How do you know it's eye level? Because it's a straight line, as you've already seen with my hula hoop example. It has to be. So that's strong evidence that the Earth is a plane and not a spherical ball. So, because no matter what altitude, and I'll show you, I'm coming up with even higher altitudes coming up in this video from weather balloons. So, anyway, we'll save that for another video, but let's continue. So the horizon that we see is always a straight line, which means it's always eye level. In order to see a curved horizon, it would have to be below or above eye level, but we don't see that. The only time we see that is when people use fisheye lenses to film. Otherwise, it's a dead straight line. Well, let's not stop at 30 to 38,000 feet. Let's go all the way up to 100 or 120,000 feet. These are a few stills from amateur weather balloon footage. Apparently no fisheye lens. And you can see it's a flat, straight horizon. And if you've been paying attention, you know what that straight line means. That's right, you guessed it. Eye level and no curvature. And for anyone that claims that they've looked out their airplane window and saw curvature, which means that the horizon would have to be below eye level, remember the footage from the amateur balloon. That's 100,000 feet. The airplane's about 38,000 feet. If you can't see curvature from 100,000 feet or 120,000 feet, you certainly couldn't see curvature at 38,000 feet. I'm just saying. And by the way, in case you didn't know, as cool as this picture is, it's not reality. The next 3 slides are from a high-altitude balloon video that used a fisheye lens.